Welcome back. In today's video we're going to be talking about polygon interior and exterior sums, meaning we're going to be adding things together. Alright, let's get started. Now we've spent a lot of time talking about the interior angle sum of a triangle, and it's all going to pay off now because the sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within the polygon. And it should be noted that we're talking about convex polygons. As you'll notice down here, I've drawn a concave polygon where it dents in. The following theorem will only apply to convex polygons. So let's get started and try to investigate this a little bit. All we're going to do is fill in the blanks for each of the boxes. We're going to answer the number of sides, the number of triangles that we see, and the sum of the interior angles. So for the first one, I see 3 sides, right? This is a triangle. And the number of triangles inside a triangle is simply just 1. And the sum of those interior angles, you already know, is 180 degrees. Now what happens when we get to a quadrilateral? Well, we have this dotted line down the center here, and I see that I have 1, 2 triangles inside. Now the number of sides here is 4. It's a quadrilateral. The number of triangles inside that can be drawn is 2. And now what's the sum of all the interior angles? Well, if you have 2 triangles, 180 times 2 is 360. So that's going to be any convex quadrilateral is 360 degrees. Now as we move this conversation along, you'll notice we've added 1 more side, and we've also added 1 more triangle. So we have a pentagon, which is 5 sides, 3 triangles, and 3 times 180 is equal to 540. So this is 540 degrees is the sum of the interior angles. Moving into the hexagon, 1, 2, 3, 4 triangles inside, 6-sided, 4 triangles, and 4 times 180 is equal to 720, or an additional 180 degrees on top of 540. And so without drawing any pictures, I think we can sort of see a pattern emerging. Now, it's not on my screen, but on your paper, up above, we had quadrilateral of 4 sides and 2 triangles, and before that we had a 3-sided situation that had 1 triangle. So if it's 1 triangle, then 2 triangles, then 3 triangles, and 4 triangles, doesn't it seem that we're probably going to keep going in the number of triangles up by 1 as we increase the number of sides also by 1. So over here we got our decagon. Decagon has 10 sides, it has 8 triangles. A nonagon, 9 sides, 7 triangles. Now what you should notice is that the number of triangles inside a polygon, convex polygon, is always 2 less than the number of sides. Now go ahead and you figure out the rest of the values that go in these blocks. Again, we just keep going up by 180 degrees from the prior box. So you should finish that up for your notes. And just for the record, the last one should be 1440 degrees. So go ahead, press pause, and wrap up these last few boxes. So if n represents the number of sides of a polygon, for instance, if we have a triangle, then n equals 3. If we have a quadrilateral, then n equals 4. So n represents the number of sides of a polygon. Then the sum of the interior angles can be found using a formula. So what did we do? We were multiplying by 180. And what was that number? It was the number of triangles that we had inside the polygon. And the number of triangles in the polygon was the number of sides minus 2. So n minus 2 is equal to the sum, right, of the interior angles of a polygon. Well, what if you wanted to know just one of those angles? Well, we have this idea of a regular polygon. So regular for polygons essentially means equilateral, okay, and equiangular. So all of the angles and all of the sides are identical. For instance, a square would be a regular quadrilateral. All of the sides are the same, and all of the angles are 90 degrees. So if you wanted to know what exactly one angle is, well, first I guess you would have to find the sum. So we would take n minus 2 times 180, and that would give us the sum. That's all of them. We'll say it was a pentagon. How many are there? 5. So if you wanted to know what just one was, then you divide by how many there are. 5. But generically, we would call this n. So if you just wanted the measurement of one interior angle, you take the sum, right? This gives us the sum of all of them, and you divide by n, the number that there is. Let's give this a shot. First, find the sum of the interior angles of a 15-agon. Well, that means that n equals 15. So first, you need to figure out how many triangles there are inside this thing. So that's going to be 15 minus 2, which is 13. And we're going to multiply that by 180. So that's 13 times 180. 13 times 180 is 2340. So that's our final answer for number 1. Number 2, find the sum of the interior angles of a 21-agon. So again, 21 minus 2 tells us how many triangles there are. Multiply that by 180. 21 minus 2 is 19 times 180 gives us 3420. So that's the sum of a 21-agon. Now we change the conversation a little bit, and we're going to want to know the measure of each, and each implies 1, right? 1 angle of a regular pentagon. Now the key fact is that it's regular. If I don't know they're all the same angles, the same measure, then none of this works. Okay, so let's get started. N is equal to 5. So the sum of all the measures is going to be 5 minus 2 times 180, which is 3 times 180, which is 540. Now that's the sum of the interior measures of any pentagon. But since it's regular, there's 5 angles. And if I divide by those 5, I'm going to get that each angle itself individually is 108 degrees. And if you check, 108 times 5 should get you to 540, so that seems reasonable. Why don't you take this same approach and you complete number 4. Press pause now and wrap that one up. Again, find the sum, and then take that sum and divide by the number of angles that's inside of it. Then move on. Now we move on to the exterior angles. Now, exterior angles are a piece of cake. First of all, I know that the exterior angles are always supplementary to their adjacent interior angle. So we see, for instance, right here, these angles are a linear pair, so they're going to be supplementary. So let's go around and let's find the measure of this angle, the measure of this angle, and the measure of this angle. And we're simply just going to take 180 minus 61, 180 minus 79, and 180 minus 40. Press pause now and get those 3 answers. It's really important that when I ask you to press pause and calculate the answers on your own, that you do that and not just blindly copy what I'm writing. Otherwise, there is no learning experience on your end. Now, if we want to know the sum of the exterior angles, well, that just means that we're going to take these 3 numbers and we're going to add them, right? Sum implies addition. So 119 plus 101 plus 140, if you add that up, you should get 360 degrees. So the sum of the exterior angles of a triangle are 360. Well, what about the quadrilateral? Again, fill out the values of these 4 exterior angles. Take 180, subtract 71, 180, subtract 124, and so on for the other 2 angles. And let's see what you come up with. Press pause now. Again, if you go through the effort of calculating these answers on your own, this will stick. It'll be easier for you to perform well on future assessments instead of struggling and trying to memorize your way through geometry. Understanding is the key, and the only way to understand is to do the work. Right? You must do the work. Now, if I'm looking for the sum of the exterior angles, I have all the exterior angles right here. So I'm going to take those 4 and I'm going to add them, and I'm going to get, again, 360. And now this is when you start to ask yourself, is that going to happen every time? I don't know. Let's check it out. First, you figure out what all these angles are. Remember, they're a bunch of linear pairs. So 180 minus 104 and 180 minus 130 and so on and so forth will get you all those angles. And then you need to fill these out before you come check in with me. When you do that and you add them all up, you're going to realize that yes, they add up to be 360. Here too, find all of these exterior angles, fill them all in, then add them all up and confirm that you're getting 360. Now I can just give you a little quick explanation as to why things are happening like that. As we keep adding sides, the angle inside here is getting bigger. As the angle on the inside gets bigger, the angle on the outside gets smaller. And eventually, as we add enough sides to this thing, this polygon is eventually going to become a circle. And that 360 thing sounds really familiar, doesn't it? Kind of neat. So the interior angles are always going to get larger, and their sum is always going to get bigger. As that happens, the converse is happening, or the inverse is happening on the outside. It's getting smaller and smaller, and eventually we'll go to 360 degrees of a circle. Again, what happens when we want to get one of those exterior angles of a regular hexagon or any kind of polygon? It must be regular so that I know that it's equal angular and equilateral. Well, I'll take the sum and divide by the number of sides, and that would get me each interior or each exterior, depending on what that sum is. Well, if the sum is always 360, I guess 360 divided by n is going to give me each angle. So for a hexagon, then I guess all we're talking about is 360 divided by 6. Well, 6 goes into 36 6 times with a 0 left over. So I guess 60 degrees is the measure of a regular exterior angle of a hexagon. So the final answer here is 60 degrees. How about if the exterior angle of a regular polygon is 12 degrees, how many sides does it have? Well, that's an algebra question. If you take 360 and you divided it by how many sides it has, you get the measure of each angle. So what's 12? Is 12 the sum? No, I already know the sum is 360. Is 12 the number of sides? Nope. 12 is the measure of that each angle. So if 360 divided by n is equal to 12, then I do a little bit of fancy cross multiplication. And when I cross multiply, I'm going to get 12n is equal to 360. Divide by 12, divide by 12, n is equal to 30. So n is equal to 30, and so I'm just going to write n is equal to 30, or 30 sides, or it's a 30-agon. That seems like a nice answer. How many sides does it have? 30. So that was number 5 and 7. So what I want you to do is complete any missing problems, fill in all blanks on the handout that I didn't cover yet. Right? So the first 2 pages here, make sure that you got everything squared away, then move on. Now that you've got everything squared away, buttoned up, I think we're ready to move on. So let's just revisit. Now, of course, this is a great index card set of information. This is just going to clarify everything that we just talked about. The sum of the interior angles of a polygon. Okay, the sum is going to be the number of sides minus 2 gives us the number of triangles inside times 180 would give us the sum, total sum. Now if you take that total sum and you divide by the number of sides it has, you get the measure of each angle. Now the sum of the exterior angles is pretty simple, right? That's just 360 degrees. That equals the exterior sum, right? This is the interior sum, this is the exterior sum. If you want one measure or one angle, then 360 divided by n will give you one, or each angle of a regular. And if you want the number of sides, it's simply going to be 360 divided by each angle measure. That would give you the number of sides. So those are reversible. Now let's take this and apply it as much as we can. And let's mix in some algebra, of course. Now I think you should be able to complete 1 through 4 on your own. And now number 5. You have 5 angles of a hexagon, right? So a hexagon has 6 sides. And you're given 5 angles. What's the measure of the 6th angle? Well, all I really need to know is, what do they add up to be? So 119, right? 119 plus 129 plus 104 plus 139 plus 95 plus, I don't know, equals the sum of a hexagon. So I come off on the side and I say a hexagon has 6 sides minus 2 times 180 is equal to the grand sum. And that sum is what's going to go right here. Now if you recall from filling out the front of the notes, that was 720 degrees. So I got 1, 2, 3, 4, 5, 6 angles. Now I'm going to combine like terms and finish this one up really nice and sweet. Now you should have gotten 586. I'll subtract 586 from both sides, and I'll get a final answer of x equals 134 degrees. And that is the measure of that last angle. Piece of cake. Find the sum, take what you got, subtract it from the sum, and you'll get what's left, that single angle. Now I'm here to help you take good notes and show you how to apply them to solve some new problems. So here's your notes, and then you got a new problem over here. What you want to try to do is look back at your notes and line up. Do I have some notes that kind of look like this problem? Now, I'm certainly here to get you through the tough spots, but you want to start to really learn to use your notes to help you through this problem-solving process. That's mainly what we're here to do, is to teach you how to swim on your own. Now we got something a little bit different. It said that the sum of the interior angles of a polygon is 1620. How many sides does it have? So we're looking for n, and they gave us the sum. So I know that the sum is n minus 2 times 180 is equal to the sum. Now they gave me the sum. That 1620 is this number right here. So I'm going to say n minus 2 times 180 is equal to 1620. Now good algebra says that I'll do the inverse. Right? I want to get n by itself. I see a multiplication sign right there, so I'm going to divide by 180 on both sides. And I'm going to get n minus 2 is equal to 9. Well, now that's a piece of cake. Add 2 to both sides, and we get n is equal to 11. This is an 11-agon. Just for the record, we'll double check. 11 minus 2 times 180 is 9 times 180 is equal to 1620. Check. This is our final answer. 11-sided. Okay, I would like for you to finish the rest of this page. See me or a friend for help if your notes don't help. Try to work it out on your own first. Okay, press pause. When you're done with that page, check in when you're done, and that'll about do it. All right, thanks for watching. We'll see you next class.